Hello again, Narek is here, and today I'm going to talk about how to solve linear inequalities or linear inequations. So, what do we mean by inequations or inequality? So, let's start. Let's say we have ax plus b smaller or equal to 0. Similarly, we can have the case of ax plus b strictly smaller than 0. In the first case, it could be equal to 0. In the second place, no, it should be strictly smaller than 0. How do I solve? So I should say ax is smaller or equal to minus b, or same thing here, ax smaller than minus b. Now, right now I should talk about the sign of a. Of course, I'm taking a different than 0. So if a was positive, the root or the solution will be x smaller or equal to minus b over a. Similarly, if a was positive, x will be strictly smaller than minus b over a. What about the case where a was negative? In case a was negative, you should switch the sign. So x will be greater or equal to minus b over a. So if a was again negative, you should say x is greater than minus b over a. Now, your solution is x smaller than a certain value, which we called in this case minus b over a, or greater than minus b over a. How do I represent them? How do I write them in form of a solution? Very easy. You can say, for the first one, this is s is equal to, from the interval from minus infinity to minus b over a. The bracket should be closed because I have equal. In this case, it will be s is equal to from minus infinity to minus b over a, but the bracket will be open since it's strictly smaller. Now, what about the second case? In this case, we will have s is equal to is greater, so it starts from minus b over a, from minus b over a to plus infinity. The brackets are closed for minus b over a since I have equal to greater or equal to minus b over a. As for the second part, you will have s is equal to, from minus b over a, the bracket should be open, so until plus infinity, and this is how you have for this case where x is strictly greater than minus b over a. This is the general form. Right now I'm going to take an example and we're going to solve each example by itself. All right? So let's take our first example. We have 2x plus 3 smaller than 5. The first step that you should be doing is to say 2x is smaller than 5 minus 3. So 2x is smaller than 2. X is smaller than 2 over 2. X is smaller than 1. This is, of course, your solution, but you have to write it down in this way: s is equal to smaller than 1, so it could be 0, minus 1, minus 2, minus 2.2, etc. until minus infinity. So it starts from minus infinity until 1. The brackets are open since it's strictly smaller than 1. Now, one of the most important things is also to know how to represent this on the axis of abscissa. So this is your axis of abscissa. your origin O. This is the value 1. So you can say the solution is from 1. 1 is not included. That's why it should be in this way until minus infinity. There is another representation on the axis of abscissa, so it's 0 and this is 1. You can simply say that it will be this shaded part. Both of these representations are okay, are fine. Alright, so I can understand that any value between minus infinity and 1 are acceptable in order to solve this inequality or this inequation. Let's take the second example. What about minus 3x plus 4 greater than minus 8? So minus 3x minus 3x greater than minus 8 minus 4 minus 3x greater than minus 12, x smaller than minus 12 over minus 3, since I'm dividing by a negative value. So x is smaller than 4. So this is my solution. How do I write it down? S is equal to, from minus infinity until 4, the brackets are open because it's strictly smaller than 4. How do I represent on the axis of abscissa? Again, this is 0. Let's say this is the value of 4. So from minus infinity to 4, this is the part which could be considered as a solution. Or simply I can draw it in this way. So this is 4, and then this will be the shaded part until 4. What about another example? So let's say we have 4 minus 3x is greater than 14, minus 3x greater or equal to 14 minus 4, minus 3x greater or equal to 10, x smaller or equal to 10 over minus 3, negative 3. So this is my solution actually. This is my solution, which could be written as from minus infinity until 10 over negative 3. The brackets are closed because it could be equal. How do I represent? In order to represent on the axis of abscissa, so you simply say this is 0, negative 10 over 3, so you have to make it a full line and then towards minus infinity, or you simply say again minus 10 over 3. This will be the shaded part, so I'm gonna rearrange it. Minus 10 over 3, so this will be the shaded part, and of course the brackets are closed in order to say that this value minus 10 over 3 is included. Let's take one last example. So one last example. What about 5x minus 3 smaller than 4.5? So 5x smaller than so I'm going to take greater than 4.5. So 5x greater or equal to 4.5 minus 3, 5x greater or equal to 1.5, and x is greater or equal to 0.3. So this is my solution in this case. S is from 0.3, so S is from the value 0.3 until plus infinity. So how do I represent on the axis of abscissa? Again, the same criteria. This is, let's say, 0.3, it's a value which is here. So it starts from 0.3, a full line, and then towards plus infinity. Or you simply say it starts from 0.3 and the brackets are of course closed towards plus infinity. You have to choose your shaded part. Alright, so this was the part where I had to talk about solving linear inequalities. I gave you several examples related to this section. So why don't you subscribe to my channel? You'll be notified whenever I upload new videos. I can also share with you my Instagram and Facebook account. You can contact me directly, or you can simply leave a comment below. That's all for this time. See you next time.